Really as good as this is not the best. This is not the highest quality.
Or obsidian. I think obsidian probably would do a better job.
Now, isn't slate what they have beneath the felt on a pool table? Isn't that what they use?
Yeah.
Slate.
Because it splits so nicely.
This is an amazing place.
The bodacious piece of milky quartz right here. It's a massive quartz crystal kind of thing. A massive piece of milky quartz there.
Oh yeah.
You can see all the slate.
There was a bunch of that. Huge bunch of it over at the Rockville campus. Right over there by.
You get the reflection off that, you can see the suggestion of cleavage in the picture. When you read the quartz doesn't have a cleavage, it's really not quite true. It's just that only rarely can you see it. Right. And this does show it. Technically, this rock is called the Ijamsville phyllite. And the line between slate and phyllite is rather slender, and this is just about on the boundary line between them. Some geologists would call this slate, some would call it phyllite, and you couldn't call either of them wrong, because it's more a matter of taste almost. Anyway, this particular rock is very different from those we've seen before. At our last stop, we were looking at non-marine, coarse, red sandstone that was deposited by rivers in a fault basin situated within a splitting up continent. This rock is much older. This goes back to the early Paleozoic, but it is North American. It's quite different from the rocks that we saw at our first couple of stops over along the Potomac River. That's because we have left the rocks deposited on the other side of the ocean. We're now in North American rocks. But these rocks are quite fine-grained, they're very fine-grained, and they were basically a deep-sea mud at the time they were deposited. There were very little in the way of current here. The water was very undisturbed, and the mud just settled slowly to the bottom of the ocean off the coast of old North America. This is pre-collision. This is before anything collided with North America. This is called the Westminster Terrain, named for Westminster, the county seat of Carroll County. And this rock was not being disturbed at all at the time it was being deposited. You can tell that by the fact that it's extremely fine-grained and uniform. Rock like that is deposited in quiet water where it's very dull. Nothing's going on. It has quite a high organic content because it was deposited in deep, depleted oxygen water. I've never been able to find any bedding in here. It's possible that someone sometime is going to find some traces of bedding in this. What you see here is the cleavage or the facility developed later on by the first orogeny, first mountain building period of the true Appalachians. Now, I called this early Paleozoic. The data for that is really by guess and by golly. There is no good way to date this. The rock itself does not, when it was formed, it contained no radioactive minerals, and so we can't use a radiometric date on it. To my knowledge, no fossils have ever been found in it. So it's dated basically by the fact that the rocks around here do show some fossils in rocks like this nearby, but this rock doesn't have any. If you want a good date on this, then you'll have to figure out a really good way to do it because nobody else has. Early Paleozoic is the best guess. It could conceivably be Precambrian because there are rocks like this not too far away that are pre-Paleozoic. But this probably is Paleozoic. If that's unsatisfying, well, yes, geologists think so too, but it's the best anyone's been able to do so far. The rock itself is high quality slate. If you're looking for something to use for shingles or pool tables or slate siding, this is where you would want to come. Now, over on the cliff over there, there is a large mass of white rock. That is a quartz vein. As I mentioned at one of our previous stops, if you're in low-grade metamorphic rocks that are cooked but only not too high a temperature, the water that's driven off the sedimentary minerals is at high pressure and low temperature as far as metamorphism goes, but very high temperature as far as the solution goes. You would definitely get a bad scalding if you stuck your hand in it. But it is hot enough to dissolve quartz, and that quartz then trickles through the cracks and crevices in the rock to places where the temperature and pressure is a little bit lower and deposits these quartz veins nearby. And I say, well, how do you know it wasn't deposited as liquid quartz? Molten quartz? Because molten quartz is fantastically high temperature. You really can't get a high enough temperature outside a really fancy furnace to melt quartz. But at high temperature and pressures, quartz will dissolve in water very, very nicely. So that's the origin of these particular quartz veins here. This particular terrain, this is the only rock from this particular terrain that we're going to see. Our next two stops are going to be across a major fault line into a different terrain. These deep water rocks off the coast of the continent, on the edge of the continent, at the beginning of the Appalachian orogeny, Appalachian mountain built big period, were shoved up and over the edge of the continents. So you find these deep water rocks pushed in a layer over the shallow rocks on the edge of the continent. That fault, that thrust fault, has then been folded into an anticline. So you find these deep water rocks here, and you can find more of them on the other side of Sugarloaf Mountain. Sugarloaf Mountain itself is the bottom of the Paleozoic, shallow water rocks that's in the middle of the anticline. It's been pushed up with the other rocks pushed on the thrust fault over the top of the Sugarloaf rocks, and then it's been exposed by erosion cutting across the anticline. Okay, any questions?
Yeah, I have a couple.
Sure.
This is a quarry, so obviously it's been mined professionally.
Yes.
And probably in an amateur fashion as well. But how far did this originally extend? I mean, did this area here extend? Because this doesn't seem to be that large, you know, like for a professional quarry. You know,
Well, this was not a large-scale quarry. This wasn't a major industrial-scale quarry.
Okay.
This would have provided an awful lot of slates for local slate roofs,
Okay.
slate siding. You know, it was not a major industry in this
Okay.
area.
All right.
It's a little bit more than our artisanal mining, but not large-scale industrial.
Okay. And the other question I had was, you know, you were talking about how there's no reliable way to date the rocks, and there's no fossils to be found in it.
No fossils, and radiometric dating doesn't help.
Exactly. And so even if you took the rock itself and say like powdered it, like you wouldn't find like the remnants of say like diatoms or radiolayer or anything like that.
Nobody has. Yes, it is possible that in either these rocks or some associated rocks, you could find fossils. It's just that none have been found yet, or if they have, I haven't heard about it.
I was just thinking that because I mean you're saying that seawater, sediments, like I would imagine that there would be some,
No, there could well have been microfossils in this. The trouble
would they
is,
get cooked out.
it could if they were here, it's highly likely that this is cooked to a high enough grade, even though it's low grade metamorphism.
Right.
It doesn't have to get very high grade
That's what I
to
was
do in the
wondering.
fossils.
Right,
But
it's not
yeah.
like it's limestone. I mean, like if it got cooked and enough pressure was put on it, I imagine you would lose any evidence
Yeah.
of like.
Now, there are places where fossils, fairly good fossils, have been found in high grade metamorphic rocks. But they haven't been, it hasn't been here.
Okay.
Now, if you do find them, you will be famous among a very select number of people. It will not make the front page of the Washington Post,
Sure.
but it might make the back pages.
Good times.
Okay? Then we can go on to the...
Turn it over here so I can see slate there, and slate on the other side. Slate on both sides, quartz in the middle.
Mm-hmm.
Okay.
And there actually might be some quartz crystals in there, small ones.
Yeah, one there and there. Some level.
Of course, these are all where you get a single cleavage. That's all a single crystal. This is all one big crystal here, as you can tell from the continuous cleavage. Well, I trust Gail will call us if he does get lost.
I think somebody called with the future coming.
You did. You didn't answer.
Oh, okay.
That's gonna be the call.
I brought along a little gadget here,
Okay. You want to start
He's
the
got a compass.
presentation?
a Brunton compass.